Okay, chemistry time. Today we're talking about matter and its... Whitley, hey, some of us are trying to learn about chemistry. Matter and its changes. The objective is summarize changes in matter. You'll notice, I'll have to pull his shirt back a little bit, or maybe I'll just have to stretch it out. But can you see this on the front of the book? No. Who has a book that is uncovered? Who has a nude book, as it were? Autumn. Can I borrow your book? The name of the book is... over this way. The name of the book is... Do you see it? Chemistry, Matter, and Change. So this is the lesson. Thank you, Autumn. This is the... Please, you need to start paying attention. That's why sometimes we don't know about things.
You need to understand percent of tea in cups. Because I just got slobber
We're gonna have to start this one over. Let's start this one over. Matter and its changes. The book is titled Chemistry, Matter and Change. Chemistry, we're dealing with matter and the changes. Basically, this chapter is chemistry. We will spend the rest of this chapter the rest of this class discussing and getting deeper into the things that this chapter is about. So the first thing we have, I always like to do this as a flow chart. I don't know if that's true, but I usually like to do this as a flow chart, where we have what is everything? Matter. No. Let's try again. What do we call everything in science? Like the all of everything?
Chemistry.
No.
Science.
Everything.
Yeah, everything. The
world. The everything. The universe.
Thank you, Taylor. Oh man, you guys are doing a good job. You're a good class. You have a little bit of work to do, and so do we all. The universe is everything. Okay, that's what we call in science everything. Everything that is and was and always will be is the universe. What is the universe divided into? What are the two broad categories of not just stuff? Oh, okay, wait, I'm going to add a third one. Thank you, Taylor. Space. Yeah, we think of this since it's an absence of something, that it's not nothing, that it ain't nothing. But space it matters, that's a funny little pun, because there's no matter in space, and that's the definition of space. But space it is important, because without space, everything...
Dies.
No, not dies, but that's how things were. If there's any such thing as before the Big Bang, that's how things were. Everything was in one pinprick spot, and then that's the idea of maybe one of the ways the universe could end is with a big crunch where everything returns to that one pinprick spot. But so without space, everything is not distinct from other things, and thing doesn't mean anything. I don't know. It doesn't. That's not really within the realm of this class. Maybe. What else is the universe, as it were, composed of? Yes?
I have a question.
No, we have to finish this first. Okay, living things which are made of matter. So one of the things is matter. What's another thing in the universe? And I don't just mean, so we can say that all things, all physical objects are in this category. But when I'm saying thing, I mean it broader, more loosely, like what other concepts are there in the universe? Feelings. Okay.
Energy.
Thank you, Gabe. Energy is what I'm looking for. Energy. Don't put feelings. That was a joke. Energy. So, are you with me? The universe is, like I say, composed of matter, which is the stuff, and energy, which is, in some ways we can think of it as the processes, the way that this behaves, the way that this changes. So when we're talking about matter and its changes, that is everything in the universe. Now, what about controversially, what about are these things in the universe? I mean, I don't know. The thing is that these are outside of, these things are outside of the realm of science. That doesn't mean they don't exist. That doesn't mean they're bad. It doesn't mean they're useless. It just means those things we don't talk about in science. Not that it's like taboo. It's not like we don't talk about it like we don't talk about Bruno. It's like we don't talk about them because they can't be tested. This, to me, let me give you an example that isn't God because that's controversial. This is my favorite color. If I were to say this is the best color, is that something we can measure in science? No, of course not, because that's my opinion. So I think it's clear to you that those things, what about my feelings? What if, when I am very frustrated because none of the students have done their bell work, is that feeling real? Well, to me it is. That's a real feeling, but it's not actually part of the universe. It's not something that can be tested with science, although actually neuroimaging technology is progressing and eventually maybe that can be tested. But for now, this is what the universe, these are the things that we scientifically call part of the, let's even specify, the physical universe. Because those other things do or may exist, they're just metaphysical. They're things that are aside from physics. So, the physical universe is composed of, I'm using quotes because, put that in quotes though, because it's not, like what the universe is actually made of is just the matter, but we're also talking about energy and space. So, what kinds of energy are there? We're just going to use this as a little kind of a brief review exercise from physical science. There is potential energy. Uh-oh. And kinetic energy. Those are the two that we mainly talk about. Potential is then further divided into things like elastic, gravitational, chemical. Kinetic energy is divided into things like temperature, we can kind of think of as a type of kinetic energy. Friction, sure. Actual movement. And there's some fuzziness between these. But those are the kinds of energy. You don't need to, that's not really what we're focused on in this class. That's more of what we think about when we're doing physics or energy dynamics. Oops, I forgot to put this picture in picture. Yeah, heat is thermal energy. I put that as temperature, but what we're mainly focused on, what we're mainly focused on in this class is matter. So that's what we're going to spend most of this time talking about. So matter is divided into, first of all, you should know this from your vocab. If I say pure substances, nope. If I say pure substances, what's the other? What's its counterpoint? What other kinds of matter is there besides just pure substances? Mixtures. Let's go down mixtures first. What are the two kinds of mixtures? Pure substances, mixtures. What are the two kinds of mixtures?
Water. That be one?
Like tap water is, yeah, but that's not one of the kinds of mixtures. Not one of the categories of mixtures.
Remixed.
No.
Come on, buddy. You did your vocab, I thought.
I really did. Heisenberg. Awesome.
It's not a discussion if you're not also saying the things to me.
Two or more pure substances.
Yeah, so what though?
Oxygen.
What are the kinds of mixtures?
Water. You can have oxygen.
You have chemical mixtures.
Has anyone done their vocab?
Yeah.
What are the two kinds of mixtures?
Oh, heterogeneous
Oh,
and
homo.
homogeneous.
Yeah.
Yep. Heterogeneous. Heterogeneous
Get your mouth off.
mixtures. And homogeneous mixtures. What's the Greek prefix hetero mean? No, try again. The opposite of that. Opposite. Different, yep. What's the prefix homo mean? Same. You can remember this because a heterosexual person is someone who prefers the opposite or the different sex, and a homosexual person is someone who prefers the same sex. So hetero means different, homo means same. So a heterogeneous mixture is one where you can tell, you can visibly usually, but you can tell the differences between the different components. You can tell observable difference between components. What do I mean by the word components? What's a component?
A chemical.
Not necessarily. What's a component? What's the... Yeah, one of the components of your boy David Keim is this arm. What's the layman's way to say that? Yeah, what's the layman's way to say that?
Thing.
One of the components of this keyboard is the P key.
It.
There she is. Well, it's a blank of the keyboard. Part. Yeah. So when I say components, I mean part. A homogeneous mixture is one where there is no observable difference between components. So the two things that make it up are spread about in such a way that you can't tell one part from the other. An example of this, give me an example of a heterogeneous mixture. Give me the classic example of a heterogeneous mixture. Pizza. Can you tell the crust from the cheese from the pepperoni? Yeah, the pizza as one object is a mixture of crust, sauce, cheese, pepperoni. Can you tell the difference? Yeah, of course you can. You can what if your mama buys a pepperoni pizza but you don't like pepperoni pizza and you like cheese pizza? What could you do? You could take the pepperonis off, but it's a heterogeneous mixture. Okay, a homogeneous mixture, for example, we'll say salt water. Now, what if your mama buys you some salt water, but you don't like salt water, you only like plain water? Can you take the salt out of the water? Yeah, you can't physically, you can't mechanically, you can't reach in and be like, I don't like this salt, and just put them over your shoulder, right? You can't do that because they're bonded. You can, there are ways to separate a homogeneous mixture. Ways to separate mixtures. These are all vocab words too, I think. Ways to separate mixtures. What's one? Yeah, what do we call it? When we separate them by boiling point, we call that what? What process is that?
Distill.
Yeah, distillation. We separate them by boiling point, that's called distillation. By solubility. What's that one? By how soluble they are in a different solvent.
Put other substances in. Chromosome. Chromatography.
Yeah, you got it. Chromatography. Nice job.
That's definitely not a vocab word, but we'll say.
What about this one? By magnetism. There's all different ways. I'm going to put down here, etc. There are all different ways to separate mixtures. By magnetism, what if, like I'm saying, if you had a mixture of sand and iron filings, they're all mixed together. Could you hypothetically, could you reach in and pick out every single sand and every single iron filing and separate them? You probably could. It might take you your entire life. But could you do that? Yeah. But an easier way would just be run a magnet over it, and the iron filings would be attracted to the magnet, and the sand would not. So there's all different ways. What about this one? I'm going to press
Before
on
we
it.
go any farther, what does this say after observable difference? Lexicon?
Difference.
Between.
Between.
No, the one on the left of it.
Between components.
Yeah, right there.
Lexicon.
What about by density? What do we call that? Yeah, rho. Good. Rho. We call that centrifuge. You've never heard of a centrifuge? If you've ever had your blood tested, they put a little drop of your blood in the machine. It goes, and then it spins your blood and it separates it into the platelets and the red blood cells and the white blood cells and the plasma. And it does that by their different densities. The ones that are more dense will be further out in the circle than the ones that are less dense.
Oh yeah.
It's a centrifuge.
I can watch.
Okay? And this is true for both homo and heterogeneous mixtures. What's another name for a homogeneous mixture? Another name for it.
Spaghetti.
No? Solution. A solution. A solution is just another name for a homogeneous mixture. Okay, what about, I'm going to erase all this. Is that okay? What about mixtures? Does anyone have questions about mixtures before we move on while everyone's still writing them down? Questions about mixtures?
Ways to separate mixtures. We need to write that down, or will it not?
It will be on the test. You don't necessarily need to write it down. It's in your book. I mean, there are vocab words.
Just
Did you say
what if we just run
heterogeneous
around like
is
distillation?
No, homogeneous mixtures are solutions. Homogeneous mixtures are solutions. There's a really cool table that I like a lot on page 81 that just has examples of different types of solutions regarding the different states of matter. I'm going to show it to you on the camera here real quick. It's this table. Oh man, I'm really bad at everything. This table is a cool table. So depending on the different states of matter of a homo and heterogeneous mixture, for instance, a gas dissolved in a gas, that's air. Air is a gas dissolved in a gas. Like there's nitrogen out here, there's oxygen out here, there's a little bit of argon, there's carbon dioxide, and they're all just mixed together. And that's a mixture. They're all gases, but they're just mixed together. What would be an example of a gas dissolved in a liquid? A gas dissolved in a liquid. No, that's the other way around. That would be a liquid suspended in a gas.
Gas suspended in a liquid.
Gas dissolved in a liquid. You've probably got one in your bag. Give it to me.
A pen.
Probably no.
Chromebook gas.
No. Gas dissolved in a liquid. Do you have that in your backpack? 'Cause you should.
Sharpie?
No.
Jewel?
Yeah.
No, pencil.
You might have this in a container in your bag.
Pencil.
Like pencil lead?
I don't.
Okay, let me give you another hint. Kyler Gorsma definitely has this dissolved, a gas dissolved in a liquid in her bag. Is that a liquid at all? No. What kind of liquid?
Pop?
Like a pop, like a soda pop, or a Monster Energy drink. There's a there. Look at the Gabe has a gas dissolved. How can I undissolve this gas in the liquid? Look at that. So look, now all the gas has come out. Is this diet, Gabe?
Wow.
No. Is this? So is there? Is there still gas dissolved in this liquid? Yeah, not as much. Some of it has come out.
No! Give me my
There we go. Wait, I gotta get more.
No! Mr. Khan, please, I beg of you, Mr. Khan, no!
Ugh, smells like Gabe. Let's try to get all the gas out of this.
No!
What's that taste like? What's that taste like when you get all the gas out of the liquid?
I'm gonna hate you. No!
Hey, I hope you learned a lesson, Gabe. Don't throw things in class. And don't bring that. Okay, what about a liquid dissolved in a liquid? What would be an example of a liquid dissolved in a liquid? Yes.
Guys, say something. I think it's
Not yet.
So I have like
Okay, yeah, that's a great. We don't normally like to use, for examples of this, we don't normally like to use biological things because they get a little bit questionable and sometimes disgusting. But saliva definitely is. There are liquid amino acids dissolved in water. Both of those are liquids and they're dissolved in each other. Okay, moving along. Moving along. Okay, moving along. What are the different kinds of? Sorry, I'm going to keep this over here. What are the examples of pure substances? There are only two. Not examples. I mean, what are the categories of pure substances? A pure substance can either be a...
Solid or a liquid?
No. But we will talk about those later on in the year. Those are the states of matter is what you're thinking of. But that's okay. Pure substances. Substances that have a set composition. Whereas mixtures can have any... Let me give you another example of this. Kool-Aid is an example of a mixture. Would it still be Kool-Aid if instead of using 1 cup in the Kool-Aid, I used 1.5 cups of sugar in the Kool-Aid? Yeah, it'd still be Kool-Aid, right? The mixture can have any variable composition. Variable composition. In these pure substances, the composition is set. They have a definite composition in both of them. What are they? What are the two examples, the two categories of pure substances? Element. Element is one. What's another one? No. A solution is a homogeneous mixture. Okay, so what if it's not just one element, but 2 or more elements combined together? What would you call that?
aluminum, silver, and gold, and iron.
Yeah, those are all elements. But what if instead of just one single element, we had 2 or more elements combined together in a certain ratio? What would we call that? Like water or gold telluride. A compound. I hope you're writing this down. It's pretty clear that you don't know this. Even though this really, really, really is all review from physical science.
I think physical science is 8th grade year.
Yeah, you're right. I didn't even think about that. But when did the rest of you guys take physical science?
Last year.
No, last year. Except for Autumn, who was the year before last. So all elements are pure substances. Give me some examples real quick. What's an example of an element and where do I find them?
Iron.
Iron. Gold.
Aluminum.
Are they only metal? Because you're only listing metal so far.
Hydrogen.
Hydrogen.
H2O.
Oxygen. Yeah. Nope. Here's how you can tell. Is because H2O is both hydrogen and oxygen. And they must have a fixed composition, a fixed ratio. So for every 2 hydrogens, we have to have how many oxygens?
2.
No, 1. What if I had this? Is this the same thing? It's hydrogen and oxygen, just like this is. No. Do you know what this is?
2 hydrogen, 2 oxygen.
Yeah, but do you know what it is? What's this one?
1 oxygen.
What is this one?
Water.
Water. You know what this one is?
Hydrogen.
No, Lily, what is this? This is hydrogen peroxide. What's your boy hydrogen peroxide do?
Clean it.
Yeah? Because it destroys everything living. Can you drink this?
Yeah.
Are you sure? Water? You can drink that?
Yeah.
Can you drink this one? When you can physically drink it, you can physically drink it. In fact, they do. If your dog needs to throw up, they give it to your dog to make it vomit because it decomposes in their stomach and makes so much oxygen they cannot keep it in. They're all bubbles come out. Yeah, you would throw up too. But what if you drank like the one that's the kind you get from the store, like the 3% one. What if we drank the 30% one like we had in the lab?
You're dead.
You'd burn. It would destroy every cell on the way down, and you would just be bleeding. It's poison.
So if
The
we
30%
would drink 3%, what would happen to us?
You get burns in your mouth and throat, and you'd throw up everywhere. Get burns in your stomach.
So that it's like
You'd have none. Why would you want to? It's not something you drink. This one is what you drink. My point is,
If I was trying to be sick for the day, and I drank
my
that,
point
what would
is,
happen to me?
are these the same thing?
You would die.
Are these the same thing?
Uh-uh.
No. Do they both have hydrogen and oxygen?
yeah.
What's the only difference between these? The ratio. The ratio is the only difference, and so that illustrates to us that the ratio, the fixed ratio of a compound, is one of the things that determines what it is. Furthermore, what's hydrogen itself look like? Hydrogen gas, what's it look like?
Bubbles.
Because it's a gas, like I just said. So it's a gas. What about oxygen?
It's a gas.
It's a gas. And what if I combine the hydrogen gas and the oxygen gas?
It floats.
A liquid.
It's a liquid. It's water. My point of this is that the things that make up a compound are completely different from the compound itself. The constituent, the things that constitute it, the things that make it up, the constituent elements have wholly, not H-O-L-Y, but W-H-O-L-L-Y, completely, wholly different properties from the compound. So even though both of these are made out of elements that are gases when they're by themselves, they're both liquids. Do you know your vocab words?
What?
Do you know your vocab words? If you remember this stuff, this flowchart I showed you, and you remember your vocab words, there's not any... the math in this chapter is what we have already done on the bell work to find percent mass, percent composition.
Read the last part.
The constituent elements have wholly different properties from the compound.
The what?
The constituent elements, what's constituent mean?
Constant.
Yeah, they make it up. The elements that make it up have wholly, what's the word wholly mean?
Jesus Christ.
No,
And
spelled wrong.
Entire.
In the whole, entirely, completely different properties from the compound. So the things that make this up have completely different properties from it. The classic example of that is that sodium is a metal. It looks like a metal. It's soft, but it looks like a metal. Chlorine is a poisonous green gas, and when they're combined, sodium chloride, which is table salt. That's just table salt. You had it for lunch. They're completely different in properties from the thing that they make up. Questions about the two kinds of pure substances, elements and compounds. Questions about mixtures? Questions about mixtures? Questions about the universe? Bye.